My name is Keith Myers, and I'm a graduate research student here in Towson University in Dr. Devadas' lab group.
My name is Nicole Handra-Giannis. I'm a junior biology major.
Hi, I'm Daryush Ali-Gulizadeh, and I'm a high school intern in the Devadas Nanoscience lab.
Hi, my name is Lynn Krasinski.
Dave Stevens.
Ali Chavez.
My name is Pierce Brown, a junior chemistry major here at Towson University.
My name is Macy Hakeem, and I'm a junior at Towson High School.
I'm Cameron Langford. I'm a graduate student here at Towson. I study physics.
Hi, I'm Benjamin Ralpham. I'm a student at Towson High School.
Samantha Kanoski.
Years now.
Nick Rosala.
My name is Wilson Turner. I am an alumni of the Devadas lab group.
Hi, my name is Samantha Coddington. I'm a senior research assistant at Towson University.
My name is Alex Schmidt. I'm a senior from Manchester Valley High School.
I'm Jaden Labarez III. I'm a general physics major and I'm doing undergraduate research under Dr. Devadas.
Hi, I'm Mary Kimcheva. I'm a senior at Eastern Technical High School.
TEMs usually traditionally were used only for transmission electron microscopy, these big huge machines. But due to modern technology, even with an SEM, we can measure samples in the transmitting mode as well.
I work in her laser lab down here in the basement, and we perform optical trapping experiments. So we're trapping silicon microparticles with an optical trap. So we got a little silicon microparticle there, and we can also manipulate the particle within a few microns. This is also relevant to any type of quantum information systems. A lot of the computers that they're using are trapping atoms using optical trapping. This can also be used to cool the atoms as well down to the ground state, so you can use them as basically qubits, quantum bits.
I do chemistry research, which allows me an interdisciplinary approach to how I can use these gold nanoparticles for enhanced biological imaging.
So what I will be doing is I'll be running fluorescence on my gold nanoparticle product. I am interested to see the intensity of my product at a desired absorbance. So the first thing that I do is I take my desired solution and I run it until I have a spectra of 0.1 absorbance. Once I have the desired absorbance, I will take that same sample and bring it over to our fluorometer machine. So the first thing I do is insert my sample. At the same 0.1 absorbance will be my excitation. I will have a desired emission, and I will run my scan. From this, I will determine the counts per second or intensity of my product at a desired wavelength.
Currently, I'm looking at my gold nanoplates through the optical microscope. I synthesized these yesterday, and I'm trying to see if there are presences of actual nanoplates. As you can see on the optical microscope, there's presence of a lot of nanoplates, like the triangular and hexagonal nanoplates, and I'm going to use this to determine the yield of my product and compare this to previous products I've made.
My project is the synthesis of air-stable, gold-coated, iron and cobalt nanoparticle-based ferrofluid, which in short is just liquid magnets. I want this, and I want to coat it with gold, the smallest particles, so that it can be used for magnetic drug targeting.
Specifically, I synthesize nanoclusters for breast cancer research. It's important to make a dilute solution because if it's too concentrated, you might oversaturate the instrument and you might get faulty results. It's important to wipe the sides of the cuvette in order to minimize any absorbance of any other materials.
So in the cuvette, I put in a dilute sample of the gold that I created, and this machine measures the absorbance of the material.
What I work on is optical trapping and taking images of the SEM. I take images of samples that are made by the people who do chemistry in our lab group. And the idea is that since we work on nanoscale synthesis, we need to actually take images to make sure we're making what we want to make. Nav cam right here is just to show you where the emitter is and basically how close it is to the stage. You don't want it to bump because it can damage the sample. So this just gives you a video, basically premise of what's happening with the stage so it doesn't bump.
So my project is to synthesize gold nanoclusters to do light harvesting applications, which is storing energy inside of the nanoclusters. So this is a rotary evaporator. You use the vacuum to evaporate the product. You put dry ice into the cold chamber with isopropanol to allow the solvent to condense without it actually being sucked up into the vacuum.
I'm currently researching into the electrochemical characteristics of organic and water-soluble gold nanoparticles. We want to see the oxidation reduction potentials in different gold nanoparticles dependent on the ligands that are surrounding the gold cores, and we want to see the electron transfer between these two. These have direct applications to solar fuel cells, and it also increases the characteristics of a capacitor.
My project focuses on nanobar synthesis, and I test how different metal ions affect the size and shape of nanobars.
I'm currently an undergraduate at the University of Chicago, studying chemistry and molecular engineering, and I plan on going to grad school to obtain a PhD in chemistry.
I started this research about a year and a half ago, and it has definitely changed my life.
Dr. Devadas' Nanoscience lab has allowed me to pursue biomedical research, something that I'm very passionate about.
To pursue a PhD.
Gain more experience in the biology realm.
It helped me realize that research is the career path that I want to take.
Having the opportunity to work in the Devadas lab gave me a great background in nanotechnology and research.
A lot of experience.
To research go-life approach, to explore different areas of science, how to manage a long-term project, which is very different from high school lab experiments.
To show colleges that I have potential in the field of chemistry and physics.
I look to get my PhD in a related field, something nanoscience and organic chemistry related, and if I was never a part of this lab, I never would have gone that direction with my life. So I owe a lot of that to Dr. Devadas.
The goal of the lab has helped me prepare to get a job whenever I finish my bachelor's degree this summer.